Pause. This is not CGI. This is a group of humanoid robots performing kung fu, live, under stage lights, in front of one of the biggest audiences on Earth. And the clip you're watching, it exploded online. People were sharing it like it was the first real welcome to the future moment of 2026. But here's what makes this more than a viral robot stunt. These robots aren't just doing one trick. They're moving as a synchronized cluster. Tight spacing, rapid direction changes, props in hand, and no collisions. That's the part that should make you stop scrolling. So today we're going deep, about 10 minutes deep. I'll break down the performance move by move and show you the world-first feats. I'll explain the training pipeline, motion capture, simulation, reinforcement learning, and the tech that powers this. Then we'll do a fair comparison. East versus West, Unitree versus Tesla Optimus versus Boston Dynamics, what's hype, what's real. And yes, the Jackie Chan angle is real. Same night, same gala, and the robots did Drunken Fist so clean. People joke they out-kung fu'd the legend. Let's unpack what actually happened. Before we zoom out to the scale of the event, I want you to notice one detail. Watch the spacing. Look at how close they are, how fast they shift formation, how they recover instantly after explosive moves, and nobody clips, nobody freezes. That's not just choreography, that's real-time balance, perception, and coordination. Physical AI is leveling up fast. The 2026 Spring Festival Gala isn't just a TV show, it's a cultural juggernaut. It aired live on February 16th. And for robots, this stage is brutal. It's bright, loud, and packed with variables. Glare, reflections, and vibrations. Unitree had appeared here before, but 2026 was a level up. A full martial arts spectacle, fully autonomous and collision-free. Dozens of compact humanoids, around 132 centimeters tall, stormed the stage in bright orange kung fu outfits. They performed alongside masters from Hanan Tagu. Human discipline meets machine control. And here's the irony. Jackie Chan was in the same lineup. When the robots hit Drunken Fist, it felt like a bold mirror moment. Behind the scenes, prep involved tuning for glare and floor vibrations. A 2% slippery surface can end in a faceplant. So the big question, what exactly did they do on that stage that made people say this is different? Let's break it down. The routine opens with synchronized martial forms, Liu He-style motion. From a distance, it looks like dance. The key is control. Then it ramps up. Parkour-style vaults, aerials, and flips with landings that look unusually stable for small humanoids. And then, props. Staffs, swords, and nunchaku. This is where robotics usually fails. Why? Because hands are hard. Prop handling exposes everything. Grip, timing, and impact absorption. The most impressive part is the transition. Now, Drunken Fist, it's supposed to look sloppy, but it's controlled sloppiness, misdirection, and sudden bursts. When robots do this convincingly, it suggests they're controlling unstable dynamics in a way that looks organic. That's why the internet was shocked. There were spectacle moments too, like a larger model in Monkey King costume. It frames robots as characters, not appliances. So, what are the world firsts? Bucket 1, cluster coordination. Bucket 2, dynamic recovery. Bucket 3, dexterity with props. The internet turned it into a war of narratives. Pure awe versus sci-fi fear versus the skeptics who called it staged. If the underlying control is real, then it's a preview of what robot fleets can do in factories and beyond. How do you train this? Step 1. Motion capture. You use real martial artists to give the learning system a high-quality starting point. Step 2. Simulation. You run millions of trials so the robot can fail without breaking hardware. Repetition at scale. Step 3. Reinforcement learning. The robot learns policies, how to choose actions under uncertainty like lighting or floor friction. Then sim-to-real transfer. You rehearse until the motion survives reality. It involves falls, a lot of falls. That's how they learn. What you saw on stage wasn't just a trick, it was a system that combined perception, control, and training. Now, let's talk hardware. Okay, tech time, but we're doing it the retention-friendly way. Every spec must explain something you saw. First, size and mass. A compact humanoid, around 132 centimeters and roughly 35 kg, can be agile, and lower mass means impacts are easier to survive and control. That helps with repeated dynamic movement. Second, joints and torque. You'll see claims like up to 43 high torque motors and large joint ranges. Hips, knees, ankles working together to create stable landings and fast recovery. You don't need to memorize the degrees. You just need to understand the effect. Bigger range plus higher torque equals more control during unstable poses and quick transitions. Third, perception. Systems often combine depth cameras and LiDAR-type sensing for mapping and spatial awareness. Why does that matter? Because tight formations are a perception problem. The robot must understand where it is, where others are, and how to adjust in real time, especially when stage lighting tries to blind sensors. Fourth, hands. Dexterous hands. More degrees of freedom are the difference between cool robot flips and robot that can manipulate the world. Props are a brutal test. Grip, timing, impact absorption, and mid-move correction. Fifth, battery and sustained performance. Heavy dynamic movement burns power. If you can run for hours, you can rehearse and perform without constant swaps. And then the elephant in the room, price. When a humanoid is talked about in the roughly 13.5K, 16K zone, that changes the conversation from prototype to scale. because even if that price shifts depending on configuration, it points toward mass production pressure. Now, you also hear about coordination systems. Rapid scheduling, multi-robot variables, collision avoidance. This is the invisible layer behind the performance, real-time planning. That lets a cluster move quickly without turning into a domino pile. And that brings us to the next part. Unitree wasn't the only robot on stage. This wasn't just one company flexing. This looked like an entire industry showing up. Unitree's Kung Fu performance grabbed the headlines. But it wasn't the only robot segment. Multiple Chinese companies featured humanoids in comedy sketches and interaction scenes. Things like handling small tasks, performing staged household actions, and playing roles that make robots feel normal instead of alien. And that's why some people called the gala a coming-of-age ceremony for the industry. Not because every robot was perfect, but because the message was clear. This isn't one lab in isolation. It's a supply chain, a set of manufacturers, and a public platform saying humanoids are here and we're iterating fast. Now let's do the comparison everyone wants, East versus West. But we're going to do it fairly. So does this mean China crushed the West? The honest answer: it depends on what you measure. If you measure dynamic movement, coordinated spectacle, and showing lots of units at once, this gala performance is a strong signal. If you measure long horizon usefulness in messy real jobs, warehouses, homes, unstructured environments, the race is still open. Boston Dynamics has been the reference point for athletic robots for years. Atlas-style movement is incredible. But gala-style autonomous clusters, props, and synchronized performance are a different category of problem. Tesla Optimus is often positioned around practical manipulation, repetitive tasks, object handling, and eventual deployment. But it's not currently known for doing 3-meter aerials or martial arts props. Different priorities. So here's the real takeaway. Unitree is demonstrating control plus scale plus coordinated motion. Tesla is selling a story about mass production and practical labor. Boston Dynamics is still a benchmark for athletic capability and engineering excellence. And the next phase of the humanoid race is going to be less about viral clips and more about reliability. Can you do the boring stuff safely every day without breaking at a price that makes sense? Now let's finish with the part people care about most, real-world impact, and what I think happens next. Hype aside, this is why the gala matters. It shows physical AI trending from clumsy viral prototypes toward repeatable skills. In factories, the most valuable thing isn't kung fu. It's coordination, multiple robots moving in shared spaces without collisions, adapting in real time, and recovering from errors. If the scheduling and control layer behind the performance is real and generalizable, you can imagine clusters doing logistics movement, sorting, and assisting assembly. In homes, the value isn't flips either. It's safe movement, stable balance, and manipulation. But the reason the Kung Fu clip matters is it proves dynamic stability. And stability is the foundation for real assistance, carrying items, supporting elderly people, navigating clutter, and doing chores without falling. Now, job anxiety is real. People see this and think, replace humans. The practical reality is usually slower. Early deployments start in controlled environments. Warehouses, factories, pilot programs, then expand if reliability is proven. So here are my predictions. 3 clear bets. Bet number 1. By mid to late 2027, we'll see more cluster coordination systems move from stage demos into pilot deployments in logistics and factories, especially in regions that prioritize scale fast. Bet number 2. Pricing pressure will push humanoids toward volume, meaning you'll see more units shipped even if each one is still imperfect. Iteration at scale is how the curve accelerates. Bet number 3. The next viral moment won't be kung fu. It'll be boring. Robots running real shifts, doing repetitive work reliably, and making companies money. That's when the narrative changes from wow to oh, this is actually happening. And that's why this gala performance hit so hard. It didn't just look futuristic. It looked like the first step toward normalizing humanoids. All right, your turn. What impressed you most? Control, flips, or hands? Comment one word so I can see where you land. And if we hit 1,000 likes, I'll do a follow-up that's actually useful. How you train humanoid skills. The pipeline, the constraints, what's real and what's hype. If you enjoyed this kind of deep breakdown, subscribe. Because physical AI is moving fast, and 2026 is starting to feel like the inflection year. Thanks for watching. See you next time.